What's up guys? Today I'm going to show you how an electric doorbell works using the principle of electromagnetism. The doorbell components are very simple. You have two tone bars which create the sound. You have the iron core wrapped with the wire coil which both make the electromagnet. You have the spring that pushes the iron core back. You have the switch, which in this case is the button of the bell. You have the transformer, which is the main supply, and you have some wires that completes the circuit. The mechanism used in a doorbell is relatively simple. You press a button that completes a circuit that makes the sound. Doorbells are low voltage devices. This means that they require relatively low energy to operate. An important part of the doorbells is the transformer. The transformer converts regular volts, like 120 volts, into lower voltages, between 6 to 16 volts, depend on the doorbell. At the heart of the bell is the electromagnet. Electromagnet is the wire coil wrapped by the iron core. When the electricity passes through the wire, it creates a magnetic field across the wire. This is commonly known as simple solenoid. This picture here shows the magnetic field created by the current. Just like the magnetic field of a permanent magnet, the magnetic field of an electromagnet has two poles, the north pole and the south pole. Because the current is flowing that way, and according to the right-hand rule, we can notice that the direction of the magnetic field will point to the North Pole. As long as the current is flowing, the iron core will be under the effect of the electromagnetic field. Iron is considered a ferromagnetic material, which means that magnetic fields can induce temporary magnet charges. This characteristic allows the solenoid to accelerate the iron core through its center. When you press the bell button, current will flow through the electromagnet, which will cause the piston to strike the right-hand tone bar. It will also cause the spring to compress. When the piston hits the right-hand tone bar, it produces the ding sound. When you release the bell button, the current will stop flowing to the electromagnet and the magnetic field will collapse. At this point, the spring will stretch back, which will snap the piston back to the left where it hits the tone bar on the other side, which will cause the dong sound. And that's how electric bell works. As you can see here, this is an animation for the doorbell. So when I click the doorbell button, the circuit will close, which will require the iron core to hit the tone bar and produce the sound. When I release the button, the spring will stretch back, which will cause the iron core to hit the other tone bar. And that illustrates everything.
Hey guys, today I'd like to use the electric cars, or how some people call them, the e-cars, as an example of the application of the electromagnetic course we covered this semester in the real life. So I'm taking you to Auto Elegance, is an auto shop owned by a friend of mine, to take a look at 2014 Nissan Leaf. It's an electrical car, Nissan Leaf, produced by Nissan company, and just as any other electrical car, has four main components. It's very basic. The first component is the electrical motor. The job of the electrical motor is to produce enough power to make the car move, to spin the wheels of the car. The second part is the energy storage unit, which is in this case the lithium-ion batteries. It's very lightweight batteries, lays on the frame of the car right underneath the seats. So it's really hard to get into them, but they are just like the batteries we use in our laptop. So I brought my laptop battery to show you. Look at here, lithium-ion. The third part of the car is the electrical controller. Just as the name applies, is like the job of it is to control how much volts is going to go from the batteries of the car to the electrical motor. The fourth part of the car is the battery chargers. If we take a look here, we're going to see two kinds of chargers. The first charger is called the normal charger. We can plug the cable to here, the other end of the cable goes into the wall, and we can do this at home. It's going to take 18 to 20 minutes to fully charge the car, which is going to give us 100 miles to drive, and it's going to cost us $1. The second charger, called the quick charger. This one, we can go to the dealer and charge the car for free, and it's going to take us between 30 minutes to an hour to fully charge the car. And if we don't want to go to the dealer, we can go to any places that they offer these chargers, and they're going to charge us $2 an hour to charge the car. These cars, guys, can't do anything that the internal combustion engine's car can do, but for pollute. And if we look over here, the cars say zero emission. This is mean that there is zero maintenance on this car, because this car doesn't need oil change, doesn't need filters or anything. This is where the e-car term comes from, because it is electrical, it's economical friendly, it's energy friendly, and it's environment friendly. Thank you for being with us. Three.
Hi everyone, today I'm going to talk about fuses and tell you guys what actual fuse is. A fuse is actually a small wire which melt out or break out when excessive current passes through it. It's usually used in circuits, so whenever like excessive current passes through that circuit, the whole circuit is not damaged, only that fuse is break out, so you can only just change the fuse instead of changing the whole circuit. So it's used in our daily life a lot. If we look at this car, we got a fuse box over here, and it has like mainly all kinds of fuse for each and every circuit in this car. And what actually happens, like whenever excessive current passes through any of these fuses, the wire inside the fuse melts, so it's not going to affect your whole circuit. So you just have to change one of the fuses in order to fix your circuit. So if we look at over here, what actually fuse looks like is that it has a small wire inside the fuse. So whenever like a lot of current is trying to pass through this the small wire actually melts and it stops the passage of current through it, so your circuit is going to be safe. And all the electric things in this car, the lights and everything is controlled by these fuses. Thank you.
In this project, we will be discussing the circuit in order to make a flashlight. In our project, we will be using a bulb holder, a bulb, and 3 batteries, each one is 9 volts, and a switch with 2 multimeters and cables. Got everything connected in a circuit. Mohasad is going to show you how it works.
Hey guys, this is a simple version of the electric circuit that's actually inside some of the flashlights. It contains a voltage source, which is in our case 3 9-volt batteries connected in series, wires to connect the circuit, and a switch to control the circuit. And in this case we use the 24-volt bulb. So when we click in the button to open the flashlight, this was actually happened. We close it in the circuit. And when we hit in the button again to close the flashlight, we are actually opening the circuit.
Now after we connected the multimeter, Shah is going to show you how it works.
Okay, after we connected the multimeters to measure the voltage and the current, we get 21.9 volts of voltage for this circuit, and we're getting 162.8 milliamps of current through this circuit. So through this data we can calculate the resistance through the circuit, which we will show in the calculation part.
This is the circuit we just did. We have 3 batteries, each one is 9 volts. We have the bulb, 24 volts, and we have 2 multimeters, one to measure the voltage and one to measure the current. And we have the switch. So here, the voltage we got was 21.9 volts. The current we got was 162.8 milliamps, which is 0.1628 amps. And knowing that V equal IR, we can solve for R, which is V over I. And by calculating the resistance, we get 134.5 ohms. And we couldn't get a theoretical value for the resistance because it changes with the temperature. So after you turn on the bulb, the temperature goes up and the resistance goes up. On the other hand, we were able to calculate the percent difference for the voltage. The voltage we got for the calculated value was 21.9. That was the measured one. The theoretical value was 24.0, which is the bulb, the voltage of the bulb. So we could get the percent difference by dividing the difference over the average and multiply it by 100. And when I did that, I got 9.15 at the percent difference. Thank you. Today I'm going to show you. We have 3 batteries, each one is 9
millimeters to measure the voltage.